Now they are all correct. So now, what did I fix? Well, I didn't find anything wrong with the code. So I was thinking, what's so different with these two tests than the others? And I figure out why. So usually in these tests, what we see is actually when the timer has stopped, then we read. But these two tests that fail, we see that we do read the timer before we stop it. I didn't notice that before now. Also here in test 3, number 1, you can see a read timer right after the force load, but there's no stop. The timer is still running. For some reason we get a number that is further than what the real chip. Maybe, I think that's maybe. Yeah, so the way I fixed that is basically I can show you. So this is the same code that you have seen all the time, and I thought maybe something was wrong here, because maybe I should look at this instead of this, but it's correct. If there's a read and the timer was not running, it is supposed to run, but it was not running, then you load. So that's correct. But then I went into this timer thing and I think, okay, what can I make? How can I make the numbers go +1? I can look at the previous number. So that's what I've done here. It's so simple. So I wonder if in the original chip they are actually showing the number as a register. So the real number in here is counting, and what you're reading out is actually a number that is one cycle behind. If you're reading the timer when the timer stopped, this doesn't matter at all. Then you could have written this or written that. But if you're reading it while it's running, it's a different story. Then maybe, at least this is what it looks like in the code anyway. So I added timer 2 there. And then in the data out of this module, timer 2. So if you do a read 4 or 5, then you read timer 2. Now if we look closer at it again, we can see that timer B has the old code. You can see it's 2 counts behind. Well, that one is still looking at rising edge, not falling edge. And the second thing is that we don't have this extra register, so let's just add that. See, here we have timer B. Let's make a copy. Timer B2. And we're going to send that out on the data board. And if you have a rising edge, we're going to basically just copy it. And the second thing we did was, I have already forgotten. The other thing I did was, instead of looking at underflow, that was one cycle too long ago, look at timer B equals 0. So we have a head start to stop it. There you go, all programmed. Thing above is now lighting. Let's press reset, see to see what we get. And we have more errors. So I must have missed something there. Seems like it, like there, for example, that it actually stopped at 0 when it's supposed to stop at 1, 1. And then the other numbers are 1 too far behind. So yeah, I know what that is actually. I know one thing I forgotten, and that's looking only at rising edges. So in here we're going to say falling. There you go. So falling edge. Okay, let's try hitting reset once more. And there you go. Really cool. So now I got all the top answers correct except for toggle. It's not longer working. So maybe it's a cable thing or something, but I don't want to worry about that now. So happy with that. Seems like the timer A and B'ers are now actually quite comparable to the original. So next day or another night, finally it's 12 o'clock and I have the TV, finally. And then I've been doing this CIA time of day thing of Bob. It is actually running now, but as you can see, it's not. There's something weird here I need to figure out. And this is when it what it writes, and this is what it reads back. And this one's correct though, but this one is supposed to be 01, I think. And so it's not doing the same as the original, and there are no rollovers here. So the third number is rollover. So I don't know. Well, this is the first time I actually tried time of day at all. So okay, so the two first numbers there, the one to the left, the right latch, you can see there's 0000, that's incorrect. So I write 11:59:59 and it reads back 00 there. Something wrong there. But the number to the right, the green one, that's correct. So read latches and the write latches are working, I think. Now the rollover thing is not working, so I have to look at that. I think I will just print the clock down at the bottom of the screen, like the dead test card, so I can see how it works. Okay, so we saw at the screen that the write latch, it was 00 at minutes when it's supposed to be 59. And I looked in the code and there's nothing that suggests that that should happen. And then I looked in this with the VHDL code, and if you see here we have the write registers, and when we write directly into the time of day value. So there's no latching here. What's supposed to happen is that you write to one of them when you have written all the numbers, and then you write the 10th, then it should latch in everything. So basically you're just going to write to latches first, and then that might explain why it's not working. So now if you look at read registers, we see it's working also. And I changed this earlier today, so because I have this data out on every module that I've made, so I rewrote the time of day read part, and what I did is that I simplified it a lot. I had like a read flag thing and I latch output signal, but the problem with that is that it's one cycle late, and that makes it a bit complicated. It's not necessary. So instead of doing that, when we read the register, we will always start with reading the hour first. So in this process, I'm basically just latching whenever we get a read hour, and all the others I have disabled. So you can see I made some functions here to make it a bit easier in this process, so I don't have to have all this mess inside this process. That's all. I'm making these values to latch down. And then, so if you get a read TOD HR, which is the read hour, if you get a read hour, then you read the hour, not the latch, because you want the value that will be latched in the next cycle. And then the CPU will read minute and second and tenths. And when those are read, they are already latched because we read the hour first. That's actually something that's specified in the datasheet, so this is supposed to work like this. Now the datasheet says something about if you write if you write to the time of day to set time, then the timer is supposed to stop. But I mean, I don't know how important that is. I can change all of this to reflect that. However, what I want to do now is to have a latch that when you start writing hour, minute and seconds, those three are latched. They are not used, but they are latched. And then when you write tenth, all of those latches are then put into the timers at the same time as you write the last value. In that case, you don't have this rollover problem. I think maybe that's what I'm having. So I will just rewrite this function. Actually, I need some signals, I think. So maybe I should just reuse these latches then. So I'm not supposed to mix because these are read latches. So maybe I should call them read latches. Actually looks like it got worse. Except for the number to the right there, it looks correct, but the first one, right latch, got worse. So this is quite interesting. I have printed the tenths here, and there's nothing, but then I remember I used time of day for something else, so therefore there's a break on the board. I don't know. Yeah, you can see it there. There's a break. Not sure if that's time of day anyway. But if I go down here, this is time of day. You can see it starts spinning because of noise. Then if I hook it up to time of day over here, it starts to run normally. So that's good. And now if I run the test, if I hit reset now, there you can see it runs to 02. That's also interesting. Not sure why that happens, but so that means that I'm not reading back what is actually set. But really great now is that we do have rollovers here. This one is incorrect, but we do have rollovers. So it's counting. Okay, we are looking at the top structure, and now I figure out why it's not. Maybe now why it's not working, because when you read, you latch, but it's never getting a read pulse. So if you go to the timer A here, and then if we look at the read thingamabob, it looks at write 0, but actually this is not how it works, because there's no ship select in this signal. So we can't just say 0, we need to say read 1. So that means that we need to change the port also to include a read pulse. We could have just supplied the ship select here, that would have been more straightforward. I wouldn't have done this mistake. You can see I've broken it down like this. Ship select active, then it depends if read write is 0 or 1 to get read or write. So never mind, we will just insert that on the port for time of day. Then I will figure out which other registers also need that signal. Timer A, timer B, blah blah blah. There you go. Then we also need to go to the instantiation. Here. Yes. That's it. And then we need to use it. And we are using it. So let's try that. Right, that made a huge difference. Now it seems to be latching, but it's not right, latching the right number. So you can see 11000 there. So it's I don't know what to say, but yeah, that's at least something. Latching is now working, but why isn't it latching the number that it was already set? Yeah, maybe I should also say that I'm setting 11:59:59:00. So burnt did that test program, and you can see the time there is 00:12. Now at 36, it's 33, 34. There you go. So that is actually working. So something else is wrong. So it seems that the time of day is working. Maybe it doesn't like to be written and read back so fast. I was looking for this bug all night, like when 3 AM or something. Now it's the next day, it's 21/28, 24th of May, and I found why there was a problem. The first thing I showed you, actually, we figured that out already. And one of the problems was basically that we didn't have a read signal, we just used the write signal. And the write signal is here. So it's just a product of not read write and not ship select. Then write goes high. So I made another one called read. I don't know why I have split this up. I should have just put these two into the modules so you can handle it themselves. So I fixed that, but it didn't work. So we had more problems. And let me just try this. I'm just gonna borrow the TV for a moment, and we will see. So let's switch it on. There you see. Now it's correct. 11:59:59. 0, 0. So now I can write and read back really fast. That's great. So now that is working. The rollover thing I can fix, that's not working. Oh, by the way, look at this. This is totally unrelated, but I also was wondering about the time of day thing. So you can see I've put a little copy in the when I make the program. I also add the dead test. So in theory I should be able to turn this off and sorry. So I should be able to switch through here and I should be able to get dead test in the second image. If I'm lucky. Yeah, there it is. And the funny thing is that reading did work yesterday. So reading the clock works, but latching did not work. So there's a big difference there. So there you can see it says 11 seconds over PM. That's actually correct. So I didn't explain it so very well, but what I did was in C64 Studio, when I compile the binary, I also compile produce the bin file from the cart convert, and then I add the dead test after my cartridge. So let's see the code. What did I change? And why did I change it? So to understand why it can read from the chip, but cannot latch from the chip. So I was in here and I was changing this to a fixed number because I thought maybe something was wrong with a number that I was putting into the read latch. Didn't work. It was as if this latch was never written to, and it wasn't. Then I was thinking, what could be wrong, and we already fixed this read flag, but that didn't help either. However, it was crucial to have that read signal, so that was also important. But the main thing that was important was this falling edge. And the strange thing that was last night had already changed from rising to falling. And I can show you why this is important and why it's different from reading when the CPU is reading and when the chip is latching. So I can show you here. This is the read diagram. So writing is something we have done all the time. We are waiting for a falling edge. Then we check that the chip is selected, and we also check that we are in a write here. And then we also check the address, and we store the data. So that's fine. That's on the falling edge. But when I was reading this read diagram, I was thinking, okay, we have a positive edge here. But if the CPU is reading from the chip, these figures on top here, that's relative to the CPU, I think. It doesn't have to do anything with the FPGA implementation. The FPGA must present the data down here before the falling edge, such that the CPU can charge up its data input or something like that. So you have certain requirements, and anyway, so that's why I have down here just a multiplexer. That's it doesn't care if it's a read or write or anything. If it sees this on the bus, it just puts whatever latch you want to look at. No clocking or anything. However, in the top structure, we also, here are the 4 datas. We also put them out on the bus whenever chip select is 0 and read write is 1. So basically you can say that the latch comes from here, and then it goes into data out of that port, and then into here, and then into data out, and then finally to the data bus. The reason why I did this is because I want to control the tree state of the data bus in one place. So, because in FPGA you don't have tree state logic, you only have logic, zeros and ones. So therefore, you don't want tree states inside your design, except if you're dealing with a output pad. So because there you can have tree states. Anyway, so back to the problem. Why falling edge? Why does falling edge work? Well, we want to store this whenever you have a falling edge or a read. Because first we want to read hour, and then we want to read minutes, and then seconds, and then tenth. And meanwhile we are reading those, the counter can change. So that's why we want to store all of them in a latch on the first read, such that when we read the rest, they will not change. So, but that didn't work. They were never latched. So basically this function was never woken up, or this process. So, but if you look here, now you can see why that happened. Because if it's a rising edge, it happens before the chip select is low. So this never was true whenever we had a rising edge here. But on a falling edge, we did have a chip select. So that's why it's working now. The strange thing is that I tested this last night and it didn't work. So, but I had more problems. I had this problem also. So I could have mixed those two problems up or something. So yeah, but that's an easy function. Now I can remove all of this stuff because I don't think I need read flag or anything like that. So anyway, so this is it, and as you saw, it's working. I've used this display for debugging. Really happy. Now I will look at the AM, PM thing and rollover thing. Rollover is working fine, but the rest is not working. But when you set 11 AM, it goes to 12 PM, and it has this weird behavior from the AM, PM world. No idea why. So, but I want to be as close to the original chip as possible. So that's it basically. So I thought I was finished, but I forgot that when I was testing this thing, I turned the ticking off, or the functionality of the clock. And the functionality is basically take the time, put it in on a variable. You can see the variables at the top there. You can have variables in processes, and then what you do is that whenever you have a rollover situation, like the 10th are 10, then you want to increment the next. So you have a carry logic, basically. It will carry to the next. Then when seconds are 10, then you put it back to 0, and then you roll to the next. And the 10th of the seconds. And then if that 10th goes to 60 or 6, then you set it back to 0, and then you increment the next, and so on, and so on, and so on. I think that's it. So that's the way this clock works anyway. I don't think it works exactly the same way in the real chip, because I think maybe they have some comparators that checks AM and PM flags and stuff like that. Well, I'm just counting from 0 up to 1159 or something, and then I convert the number. So anyway, but here we have the clock, time of day clock. Now in the process, I know this code is working. I have simulated it 3 years ago, and it also was working the other day, or yesterday. So, but will this read-lash thing still works? That's another question. So I will try that now. Okay, let's try it. So what we're looking for here is basically the first number there you see does not roll over. So basically these two guys, and they didn't. So what I do is I read the hour, then I let it roll over, and then I read the rest. So the latch is actually latching, so that's working. And then you will see that it rollovers actually does work, so that's good. You can see we start at 12 and end at 81. That's weird, but and here we have 11 with PM. It goes to 00. No idea, but it's actually rolling over to 00. There's no 00 in the C64 CIA chip, so that's something we need to look at. But it does roll over, so that's good. So I think this one goes from 11 to 12 with a PM flag. So from 11 AM to 12 PM. Anyway, so that's the end of the video. Thank you very much for watching. And now it's the 1st of June, so it's been a week since this last video you saw now, the last clip. And it's been a lot of work just to edit, especially those two where I had screen recordings, not the previous video, but the two before that. So yeah, so now we're happy to actually do some more work. So because I don't want to make so much video such that I forget what I was working on. So when I come to the part where I'm going to edit the video, I don't know what I'm actually. Oh, did I really do that? It's very typical of me. So, but thank you for watching and see you another time.